Hello, my name is Siddhant Madhav, and today I'm going to displaying my 1512 term project. It is a physics simulator which simulates forces between celestial bodies and subatomic particles as well. They aren't restricted to a preset group of bodies. The user has the ability to input any kind of information he wants, and he will see a simulation depending on the information that he has inputted. Let's see how this program works. Let's say we want to create a electron positron pair. Let's see. We need to create two particles. The program creates enough data space for two particles. Let's see what would have happened if we wanted to create more than two particles. The program would have accommodated and would have created enough data space for more than two particles. Okay, but we'll stick to electron and positron right now. Sorry, negative. These values that I'm inputting are not random. They are values that I've calculated from before. You'll see why. Let's create a positron now as well. Oh, and these coordinates that I'm inputting are spherical in nature. It's because it's easier for a program to understand spherical coordinates better because it converts them into Cartesian as it goes along. It's hard for a user to figure out what his Cartesian coordinates are. He'll have to compute square roots and such. So I've just made it easy for the user to input his information. Okay, let's save the scenario. Now this particular system, let's call it system 1, will be saved as a text file which the program can interpret on its own. Let's save it. Now let's see what happens when we open this file. Say the system 1. Here's the file. There it is. That is an electron and positron pair orbiting each other. This is a case of binary motion subatomic particles, not usually seen, but for the purposes of displaying the powers of this program, I created the simulation. Of course, this is a very brief demonstration of what this program's capabilities are. Let's see what else this program can do. Let's talk about gravitational simulations now. How about we find what happens when you have the sun, and a random comet around it. This is information relatively accurate about the sun. Let's create a random body, mass similar to that of the Earth. Similar, not exact. Let's place it around the place where Earth is as well. Let's give it a completely different random values over here. For the purposes of display, we'll give it a radius similar to the sun, otherwise it will seem too small. Let's create a cyan body. System 2. Now let's see what happens when we open this file. There you have it. That is a body orbiting the sun, our supposed sun that I've created. Of course, this program is not limited to creating just one body. Let's see what happens when we calculate things for different bodies. This is a preset file that I've created. It will show you some capabilities of this program. That is Mercury, this is Mars, and that is a body the size of the Earth in a completely different orbit. The elliptical, obeying Kepler's laws, kinetic energy maximum at this point and least at the furthest point, as you see. This is a result of the conservation of angular momentum by celestial bodies. Of course, this is barely a display of what this program can do. All the files created from this program are text files, which just store data, and hence they can be uploaded and downloaded anywhere on the internet. So it'd be very easy for anyone who has this program to share all the systems he's created and to obtain systems as he has. I hope that you've enjoyed watching this video. Thank you so much.